Hello everyone, myself Raghuraj Singh. Basically, I'm study in section A3, and today my topic is eigenvalues and eigenvectors. The main core concept is that in linear algebra, when you apply transformations like matrix to a vector, the vector usually changes both its direction and in length. Like eigenvectors and eigenvalues are the special pair that describe the stable part of the transformations. Eigenvectors are special vectors that does not change direction during the transformation. It might get stretched, squeezed or flipped, but it stay on its same line. On the other hand, eigenvalues, which is represented by lambda, the number that tells you how much the eigenvectors was stretched or squeezed. The equation is defined by this simple equation: a v vectors equals to lambda v vectors, a transformation matrix. A is where A is transformation matrix. Basically, in this video we will discuss about introduction, which I have already given. Eigenvalue, what is eigenvalues and eigenvectors. Eigenvalues and vectors can be of two types, whether two-dimensional matrix or a three-dimensional matrix. This both the quantities eigenvalues and eigenvectors can be calculated on the Wolfram Mathematica also. We will see here what is written in this PDF, that in algebra an eigenvectors or characteristic vector of a square matrix is a vector that does not change its direction under the associate linear transformation. In other words, if v is a vector that is not 0, then it is an eigenvector of a square matrix A. If A v is a scalar multiple of v, A v is a scalar multiple of v, the condition should be written as the equation: A into v equals to lambda times v. Continuing, eigenvalues on the other hand, in above equation lambda is a scalar known as eigenvalues or characteristic value associated with eigenvector v. We can find that eigenvalues by determining the roots of the characteristic equation A minus lambda into I, which is identity matrix, where we have to take determinant of this complete, which is shown in this PDF. We will discuss here about two dimensional matrix also and three dimensional matrix also, and further in this video we will discuss that how we can calculate the eigenvalues and the eigenvectors mathematically. So let's move to the next screen, where we can see that how we can calculate all this mathematically. So basically this is the screen where I was telling about how we can calculate the eigenvalues and eigenvectors. Basically this is our first matrix. So step 1 is express this matrix in characteristic equations type. So step 1 is this. Actually this is our characteristic equation. We have make in this characteristic equation more simpler, जैसे कि a माइनस लैम्बडा टाइम आइडेंटिटी मैट्रिक्स, इसका डिटर्मिनेंट ले लिया हम लोगों ने. सो हियर is example that how we have took this expression. Basically this is the vectors and this is lambda time identity matrix. Actually this x1 x2 x3 are the eigen values, means after solving this we will get. After doing this the equation becomes like this. So after this our step 3 is to put the values in the unique equation. The unique equation is lambda cube minus sum of diagonal element into lambda square plus sum of diagonal elements of minors of diagonals minus determinant of a matrix. So exactly this is there. Here we have find how we can find the minor. So basically if we took this first row and column, we have to cancel this row and column and we have to multiply this cross and minus it. So basically similarly second we will find this and this. So third we will find basically this cross multiplication and minus. Now after this by solving this we get here according to this question we have got here the equation where it is this the unique equation is this. By solving this equation cubic equations and finding the root in scientific calculators we get this 1 2 3 the three equation of this root. Actually these roots are only the eigenvalues. So here we get eigenvalues. Now we will find eigenvectors. We will take that matrix again. Now we will put that we got lambda equals to 1 comma 2 comma 3. First we will put this lambda equals to 1 in this equation here and we will get this matrix. Now comparing these two we will get three equations, but we have to take only these two equations and by using Cramer's rule we will get the first eigenvector's value. Basically what we have done here, we have took x1 and in these two equations we have hide this and we have taken a coefficient of this here and this here and basically we have cross multiplied it. Here means like 8 to the 16 minus 8 and here similarly we get all this. So just below that x1 we have written 8, x2 6, x3 4 and by reducing it from the factors of 2 we have got here the first eigenvectors. So now similarly by putting the value lambda equals to 2 we have got here the second eigenvectors this, and similarly we can find this by putting the value lambda equals to 3 in this matrix where it is in this matrix. By putting the eigen values one by one and using the Cramer's rule we can get the eigenvectors. So here we got that how we can calculate eigenvalues first then eigenvectors. Basically in first we have used characteristic equations, then this unique equation where we have used sum of diagonal element and the sum of diagonal minors. Here we have find the minors. By adding them, we get one values of minors and we have put here and this is determinant. At the end here we have got the determinant of the main which was the question, which was the 3 by 3 question. Similarly in second part we have seen the eigenvectors. So this was the method that how we can find eigenvalues and eigenvectors mathematically. Thank you so much.